So problem 13, we have a configuration like this where we got ball A here, and this is 100 grams. We got ball B up here. This is a 200 gram ball. Over here we have ball 300 grams. And down here we have another 200 gram ball. And we have, they're connected here by massless rigid rods. But we have a coordinate system like this, where the coordinate, the origin is on block A. This is the X direction over here. This is the Y direction going up here. This is mass A, this is mass B, this is mass C, and this is mass D. We want to find the center of mass, part A, and part B, we want to find the moment of inertia I if it rotates through an axis perpendicular to the paper going through point A, so it would be spinning like this. So let's do part A first. We want to find the center of mass. It's a two-dimensional system, so we have to do it in both dimensions. But before we start out, I'm going to do the same thing I did before. I'm going to put the coordinates for each of these just to make life easier. A is at 0, 0 because it's right at the origin. B is at 0, and then we got the distances here. This is 8 centimeters. This is 10 centimeters. So this is 8, 0, 8 for B. For part C, or particle C, it's at 10 centimeters and 8 centimeters. And particle D is at 10 centimeters and 0 centimeters. So we have the coordinates for each of these. Now we're going to do it in separate parts, meaning separate for X and Y. So in the X direction, we got that the X center of mass is going to be equal to 1 over the mass total times MA RAX plus MB RBX plus MC RCX plus MD RDX. Okay? And now we just plug all that in. The mass total is just going to be the sum of all 100 plus 200 plus 200 plus 300. Okay, MA times RA, well RA is 0, so that goes away. MB, this is B up here, it also has a coordinate of 0 in the x-ray, and that goes away. MC is going to be 300 times 10, plus MD is going to be 200 times 10. And so we're going to get that this center mass in the x direction is equal to 6.25 centimeters. Okay. In the y direction, we have the same thing, but it's going to be y center mass is equal to 1 over the m total times MA RAY plus MB RBY plus MC RCY plus MD RDY. Now we're going to plug in the numbers there. This is going to be over 100 plus 200 plus 200 plus 300. On the top now, in the y direction, A still has a 0, so that still goes away. RBY is 8, so that one does matter, so we're going to put 200 times 8 for particle B. For particle C, it's going to be plus 300 times its distance in the y direction, which is 8. And then for particle D, it is 0, so that goes away, so we only have those two. And then we get the y center mass is equal to 5 centimeters. So the center of mass, as ordered pairs, is 6.25 and 5. That was part A. So for part B, we want to find the moment of inertia. And the moment of inertia, remember, is this. It's going to be I is going to be equal to M1R or MA RA squared plus MB RB squared plus MC RC squared plus MD RD squared. And we just add all those up because they're all individual points. But RA again is 0. So we get no moment of inertia from the point that's spinning at. Because remember, this is our rotation axis right here. And then MB, the mass of B, is 200 times RB, which is the radius or the distance it is away, which is 8 centimeters. Now this one we have to do in MKS units. So I'm going to convert this. This is 0.2 times, making that into kilograms. And this has to be in meters, so this becomes 0.08 squared. Okay, for mass C, this is the tricky part because it has to be this distance. So that's radius C, how far away it is from there. So we're going to get the mass of C is going to be 0.300. To figure out what RC is, I'm just going to say, oh, this is a Pythagorean theorem, right? This is 8 here. So I can just say, oh, this is the square root of 0.1 squared plus 0.08 squared. And then I square it. But notice if I square root it and take the square of that just goes away. Plus MD, which is 200 grams or 0.200 kilograms, times the distance of 0.1 squared. When I plug all that into my calculator, I get that the I is 0.0082. And now what are the units for I? Units for I are kilogram meter squared. Or we could write this as 8.2 times 10 to the minus 3 kilogram meter squared. That's the answer for part B. This is the answer for part 1. So that's how you do number 13.